going to have some fun today with this trig integral. And notice on the bottom, we're doing the same thing, the cotangent x, as we're doing the tangent x. And cotangent x and tangent x are cofunctions. And notice the numerator is exactly one of those two terms in the bottom. You know what? I'm going to rewrite this integral so the bottom stays the same, but the top is going to be the other term. That is, I maintain that this integral is the same as, in the bottom, the cotangent, square root of cotangent x plus the square root of tangent x, but on top, we're going to have the square root of tangent x dx. Now, when I add those two integrals, they both are going to go from 0 to pi still. When I add those two integrals, what's going to happen is the integrand is just going to be 1. So, let's see why this is going to happen and why you should see it. Again, the key thing is that the trig or some angle is equal, so when I say trig, I mean any trig function of an angle is equal to the co-trig function of pi over 2 minus that angle. As long as the angles add up to pi over 2, then the trig function of that, let's say theta, and the co-trig function of pi over 2 minus theta is going to be equal. What do I mean by trig and cotrig? Well, sine and cosine. Cotangent and tangent. Those are cofunctions. So, we haven't established that what I wrote down on the left equals this. So, all I can work with is the left. What I'm going to do is I'm going to make the substitution change. Let u equal pi over 2 minus x. Well, then du will be negative dx. And if two quantities are equal, if you change their signs, they'll still be equal. That is, negative du equals dx. Now, so let's come down here, put an equal sign. Now let's look at the limits. Right now, the lower limit is when x is 0. Well, pi over 2 minus 0 is pi over 2. But that equals u. So u is pi over 2. The upper limit is x equals pi over 2. Well, u is equal to whatever pi over 2 minus x is. Well, pi over 2 minus pi over 2, with x is pi over 2, is 0. So, the upper limit is u is 0. And we have the cotangent of x. Oh, so this tells us that x is pi over 2 minus u. So all the angles right now are called x. So they're all just going to become pi over 2 minus u. So it's pi over 2 minus u, square root of that, over the square root of cotangent of pi over 2 minus u, plus the tangent of pi over 2 minus u, times du, times dx, times dx, which is negative du. I will put the negative in front. But here's a nice thing about the negative sign. You can make that negative sign positive, or you can make the positive negative if you need to, if you switch the order of the limits. That is, now the bottom is 0, and the upper limit is going to be pi over 2, because I got rid of the negative sign. The upper limit is now pi over 2. So we're going from 0 to pi over 2. Now, here is where things come together nicely. It's integral from 0 to pi over 2. Now, the bottom, since we're adding two co-functions, we're doing the same thing to them. We're taking the square root of them, we're doubling them, we're raising them to the 19th power. Doesn't matter. This here is tangent of x, or u, I should say. What's underneath that square root sign, cotangent of pi over 2 minus u, is tangent of u, plus the square root of tangent of pi over 2 minus u. But since that's pi over 2 minus u, if I look at the co-function, that is the cotangent of just u, they're equal. Tangent of pi over 2 minus u is the same as cotangent of u. And I'm taking the square root of that. So notice all that happened was from the original problem is the denominator, the sum of the things in the denominator just got switched. But it's still the same denominator, which is great. And here's the beauty. As we just noticed right over here, the square root of the square root of cotangent of pi over 2 minus u is just the square root of tan u. But I have it again on the top. I have it right here. That's just the tangent of u square root. Okay. Now, what we can say is, one last thing, times du. What we can say at this point is that u is a dummy variable. Wherever I see u, and I'm erasing just the u, wherever I see u, I can put x. I can put x. Okay, now, this integral right here is exactly the one that I have in red here. It's exactly that. And we just showed that it equals the original integral. That is, this equal sign that I'm erasing the question mark over is now true. Okay, let's write it down neatly and let's look at it. Let's rewrite that integral. We wrote on it a bit. The integral from 0 to pi over 2 of the square root of cotangent x over the square root of cotangent x plus the square root of tangent x dx. Now, these two integrals are equal. Say they both equal to big I. So I'm going to add them together. I'm going to add I and I. That is the integral from 0 to pi over 2 of the square root of tangent x over cotangent x over the square root of cotangent x plus the square root of tangent x dx plus the integral in red, or with the red box around it, the integral from 0 to pi over 2 of the tangent of x dx square root over the square root of cotangent x plus the square root of tangent x. Now, the nice thing that happens, well, first of all, I plus I is 2I. What happens here is nice, because both integrals have the same limits from 0 to pi over 2. So I can write them as one single integral by adding them and integrate from 0 to pi over 2. Now I notice that when I add these two, that they both have the same denominator. Both denominators are the square root of cotangent x plus the square root of tangent x. That worked out nicely. So I can just add the numerators, which is the numerator of the left integral, which is cotangent x, plus the numerator of the right side integral, which is tangent x dx. But here's where everything comes together. What's in these parentheses is 1. I'm just integrating 1 dx from 0 to pi over 2. But that's a pretty standard integral. The integral of 1 dx is x, and we go from 0 to pi over 2, so we get pi over 2 take away 0, which is pi over 2. So 2I is pi over 2. But we don't want to know what 2 pi equals. We want to know what 2I equals. I think I said 2 pi. We want to know what just I equals, our original integral. Okay, so we divide both sides by 2, and we learn that I is pi over 4. That is the original integral, the integral from 0 to pi over 2 of the square root of cotangent x over the square root of cotangent x plus the square root of tangent x dx. This is nothing more than, okay, so I guess I didn't do my division right. If 2I is pi over 2, then I can't be pi over 2 as well. It's pi over 4. Sorry about that. Okay, so that integral is simply pi over 4. That finishes this integral, pretty much finishes the video. Please expect more. If you like this type of math, please subscribe to my channel, tell your friends about it, leave comments below, and please expect some more math of this type, the fun type, stuff that makes you think a little bit. Okay, thank you.